In the previous video, we had discussed about ionic radius. In this video, we are going to be talking about ionization enthalpy. An atom has the tendency to lose or gain electrons. So the quantitative measure of the tendency of an element to lose electrons is given by something called as ionization enthalpy. So it basically represents the energy which is required to remove an electron from an isolated gaseous atom in its ground state. So, for example, let's take the example of two elements, uh, sodium and chlorine. Okay, as we know, sodium is an alkaline metal and it has a tendency to lose an electron. So, the energy, so it will lose the electron very easily, which means it has a low ionization enthalpy. Whereas chlorine, on the other hand, has the tendency to gain an electron. So removing an electron from the chlorine atom will be very difficult. I mean, when you compare it to sodium. So the ionization enthalpy for chlorine will be very high. So ionization enthalpy is basically used to measure the tendency of an element to lose electrons. So lower ionization enthalpy, easier to remove. Higher ionization enthalpy, it is difficult to remove the electron. So there are two ionization, the first ionization and second ionization enthalpy. So the first ionization enthalpy is from the ground state. So when X loses an electron, it forms X plus. And when it loses another electron, then it becomes X plus 2. So generally, they say that the first ionization enthalpy is lower than the second ionization enthalpy. And this is because when this particular atom has lost the electron, the effective nuclear charge stays the same. So sorry, the magnitude of the nuclear charge stays the same. So the nucleus will pull in the electrons. Okay, and so removal of the electron from this particular cation will be relatively difficult. And so the second ionization enthalpy is generally higher than the first ionization enthalpy. Now, the various factors which affect the ionization enthalpy. The first one is size. So obviously, smaller is the size, or yeah, so smaller is the size of the uh, atom, larger will be its ionization enthalpy. Now, this is because the attractive force between the electron and the nucleus will uh, will in, will increase with decrease in the atomic radius. I told you it all comes back to the atomic radius. The bigger the atom is, the farther the electron will be from the nucleus. Okay, the valence electron, that is the outermost electron, right? So it will be easier for the removal of that electron, thereby the ionization enthalpy will be low. So the ionization enthalpy will decrease with increase in size of the atom, or it will increase with decrease in size. Both are right. Next, charge of the nucleus. Obviously, when there is an increase in nuclear charge, there will be an increase in the ionization enthalpy. This is because the effective nuclear charge, when there is higher effective nuclear charge, the nucleus will be able to pull the electrons towards it. And then it automatically becomes very difficult for the removal of the electron. Next, the screening effect. Now, the screening effect is shown by certain electrons in the atom. So when there is a screening effect, there will be a decrease in the ionization enthalpy. Basically, screening effect will make sure that the outermost electron will not have the proper effect of the nucleus. So it is all the more loosely bound. And this is called as shielding or screening effect. What happens? The outermost electrons are shielded from the nuclear charge by the inner electrons. And so the effective nuclear charge on the outermost electron is less because of these electrons. And so what happens is they are not as tightly held as the inner ones. and thereby the ionization enthalpy will decrease because it's easier to remove these electrons. I will repeat the screening effect alone once. So screening effect is shown by the inner electrons. Okay, so the inner electrons will make sure that the nuclear charge gets shielded from the outermost electrons, which means they will not face as much attraction as the inner ones. And thereby it is easy for us to remove the electrons from the outermost shell, and thereby the ionization enthalpy is decreased. Next one is the electronic arrangement. In the previous chapter, we discussed that the half-filled and the completely filled, half-filled and completely filled shells have more extra stability associated with them due to various reasons, which we discussed in the previous chapter again. So because of this, obviously the atoms which have a half-filled or a completely filled structure will have a higher ionization enthalpy because it is relatively difficult to remove these electrons. So these are the various factors. First is the size. Big, bigger is the size of the atom. Easier it is for us to remove the electrons, so lower will be its ionization enthalpy. Charge of the nucleus. Higher is the charge of the nucleus, more effect it has towards the outermost electrons, more difficult it is to remove. So higher will be its ionization enthalpy. Screening effect is shown by the inner electrons, and due to this, there is the ionization enthalpy will decrease, and the electronic arrangement, especially for half-filled and completely filled orbitals, it is more difficult to remove the electrons, and so the ionization enthalpy will increase. Right. So let's look, before we start that, there are a few things I'd like to point out. In each of our periods, the noble gases will have the highest ionization enthalpy because of their most stable electronic configuration. Now, the elements which have half-filled and completely filled orbitals will have higher ionization enthalpy than their counterparts. Now, across a period, when we go from left to right, first of all, we know that the size of the atom decreases as we go from the left to right. So the ionization enthalpy will increase because they have an opposite relationship. So lithium will have a relatively lower ionization enthalpy than fluorine. Next, as we go down the group, again, with respect to size, we know the atomic radius increases as we go down the group. So this means that as we go down the group, the ionization enthalpy will decrease. Now, let's look at the second period alone. Right. Now, if you see from lithium to beryllium, there is an increase in ionization enthalpy because of the increase in nuclear charge and smaller atomic size. The size of beryllium is smaller than that of lithium, and so obviously the ionization enthalpy will increase. Next, from beryllium to boron. If you notice, there is a slight decrease between the ionization enthalpies of beryllium and boron. Now, this is because despite the fact that boron has a more nuclear charge compared to beryllium has a completely filled s orbital, which means its electronic configuration is 1s2, 2s2, whereas boron has 1s2, 2s2, and 2p1. So this one electron is relatively easier to remove from the p orbital in case of boron than compared to beryllium. And next, from boron to carbon to nitrogen, there is going to be an increase in increase in ionization enthalpy because of the relative increase in nuclear charge and decreasing in atomic radius. But when we go, so boron, carbon, nitrogen. From nitrogen to oxygen, if you see, there is a decrease in ionization enthalpy. This is because nitrogen has a half-filled electronic configuration. So its outermost orbit, as we know, 2p electrons are getting filled up. So here you have 2p1, here you have 2p2, here you have 2p3, 2p4, 5, and 6. Okay, so here, if you notice, I said 2p3. In the previous slides, we discussed that when there is a half-filled or a completely filled orbital, it is more stable than the others. And so the ionization enthalpy for such cases will be higher than the counterparts. So here, oxygen has 2p4 as its outermost electronic 2p4 in its outermost shell, and so it is relatively easy to remove a single electron than removing one from a half-filled 2p orbital in case of nitrogen. Now, oxygen to fluorine to neon, there is a constant increase due to the increase in effective nuclear charge and decrease in atomic radius. So let's go back. So lithium to beryllium, there's an increase. Boron, carbon, nitrogen, and oxygen, fluorine, neon. All these cases, there is an increase, but for beryllium and nitrogen is relatively higher than the atom which is beside it, is because of the fact that these two have half filled in case of nitrogen and completely filled in case of beryllium atoms. So beryllium has 2s2 and nitrogen has 2p3. So these have half-filled and completely filled shells, so their ionization enthalpies will be high. Again, so similarly, if you notice, to conclude, the ionization enthalpy has various factors which affect it, but one important thing is the fact that the atomic radius has a huge role to play. So when you go for a big atom rather, when the atomic radius is relatively higher, it is easy to remove the electrons, so the ionization enthalpy is low. So ionization enthalpy increases as we go from the left to right, and it decreases as we go from the top to bottom because the atomic radius increases as we go down the group. We'd learned about ionization enthalpy. It is the tendency to remove the electrons from the outermost shell. We learned that there are two different, we learned about the first ionization enthalpy and the second, and generally the second ionization enthalpy is way higher than the first. There are various factors which affect ionization enthalpy. There is the size, nuclear charge, the screening effect, as well as the electronic configuration. And these in turn will lead to various changes in the ionization enthalpy. The trends in the ionization enthalpy as we go from the left to right, the ionization enthalpy will increase. And when we go from down the group, the ionization enthalpy decreases. We discussed about the ionization enthalpy for the second period. We noticed that beryllium and nitrogen show a unique difference. They have a higher ionization enthalpy than the element which is beside it. And this is because of the half-filled and the completely filled orbitals. Noble gases will have the highest ionization enthalpy of the respective period because of their completely filled orbitals and the most stable configuration. With that, we complete this topic. In the next one, we will be discussing about electron gain enthalpy.